This is Craig Miller, and this is a small video introducing the script I've written to create dynamic hair joints. As you can see here, this little fella is wiggling all over the place. If I stop it, we can see that some of the controls that will be created. We create FK joints and a dynamic controller. This controller gives you access to most of the attributes in the hair controller, and also gives you access to the FK and dynamic settings here. At the moment we're on full dynamics. You can also see that the curves are following where the FK is directing it ultimately, but we still have dynamics in there, so it is hair dynamics, but it's controllable hair dynamics. If you wish, you can turn the dynamics off and the tentacles or the branches will follow directly where the FK controllers are animated to. The dynamic controller also gives you direct access to the hair system. This script overwrites the normal down key hotkey and is connected directly to the hair system. So by doing that, you'll have access, quick and easy access directly to all the properties just by hitting the down arrow on the keyboard. We'll toggle between the two. So that's an example of the end product. Let's do a rig from the very beginning. This is the unrigged scene. The base has an animation on it. I just animated through the main controller with the joints here. The joints need to have unique names, so make sure your joints are named correctly and they should be correctly aligned. So we'll fire up the dynamic strand rigging. We'll select the first joint of the chain. It should be parented underneath one joint. So we'll select the first joint that is going to be the base of the dynamic rig and we'll create the rig. It creates the dynamic controls with the attributes attached to the hair system and the forward kinematics to dynamics for that particular joint chain. You see it's taken the name from the joint I originally selected. While we're here, we should attend to the FK controllers, whether they're the appropriate size or not. I think these ones are a little large, so I'll scale them down a little bit. In this case, I have the appropriate orientation to the joints, but if they were not oriented correctly, you could rotate them around the x-axis or the y-axis or the z-axis until you got the correct orientation. Once you're happy with that, go on to the next joint. Select that, create the rig, adjust the size of the controllers. The second rig will have had its forward kinematics to dynamics attribute added to the controller. Select the third one here, create the rig, adjust the controllers, and this user interface is finished for the moment. We'll close that. We can select our control dynamics, and at the moment they're set up to be following forward kinematics, so when I play the animation that's what's happening. But you can see the curves running with the dynamics here. So let's slow those down a little bit. It's probably still a little excessive, but we'll see what happens when we apply it to the joints. So quite simply, it's a very quick way to get an automatic response. The joints will be controlled by the FK controllers as well. So for an example, I can select these FK controllers, I'll give them a key here, come down to frame 50, and we'll rotate them there and there. So while we still have dynamics, it is still following the FK curve. Another feature, it has already been implemented, is the parent-child hotkey between the control dynamics and the strand hair system directly. So you can use the down arrow to toggle between the two objects, and that can make it easier to set up the attributes you need for your hair system. But before we go, we should tidy up our scene. The program has created groups for the FK controls. They are parent constrained to the parent of your originally selected joint. So in this case, it's this non-bind joint parent that this group is parent constrained to, and these as well. So we'll select these and put them in a controls group. We have a dynamic controller. This is not assigned to anything at the moment. It's dependent on, its position is really dependent on where you need it in your rig. So I've left it sitting at the origin, but feel free to move it where you need so it can work for you in your rig. The nucleus probably should stay at the top level there. If you are looking for the strand hair system node, it and all the curves have been placed underneath this no transforms group. We don't want to get multiple transforms on this, so the inherit transform attribute has been turned off for this group. So these can all sit happily in here. So we have the curves that have been generated for each of the groups. We have an original IK spline system for the original set of joints. It's driven by the FK system, and these are the follicles and the hair system output. And this, of course, is the standard hair system. I've just labeled it strand. All the hairs are attached to this one hair system under the assumption that if they're all strands of one object, they'll move in a similar manner. All the hairs are attached to the one hair system, which is also running through into the nucleus. So you can assign collisions if need be. So that's the end of this introduction. I hope you're able to use the hair system to your advantage.